Hello, I'm Jisoo from Korean University, and today I will share my recent work of captioning for text-video retrieval via dual group direct preference optimization. Text-video retrieval aims to find the most relevant text or video given a query. For example, a query describing a cat requires retrieving the most accurate video from a pool of candidates, some of which may be visually similar. And this requires models' ability to make fine-grained distinctions in order to select the most relevant match. So one straightforward approach is to use auxiliary captions generated by a captioning model, which provide additional semantic context and help the retrieval model achieve more precise discrimination. However, captioning models often produce generic captions that fail to capture these distinctions, limiting their effectiveness in retrieval. For example, these two similar videos depicting cats in indoor environments may be captioned with generic actions like walking around the room or moves around. Ideally, we want to generate captions that surface discriminative visual details such as sits up, stretches its body, and for the second video should be interacting playfully, which provide critical cues for retrieval among visually similar videos. This issue is also further amplified by the common practice of evaluating caption quality using metrics such as BLEU. We observe that the top 1 captions selected by BLEU often don't align with the top 1 ranked by retrieval relevance, where it shows the correlations to be as low as 30%. And this substantial discrepancy highlights the need for retrieval-aware captioning. So hence, to address these issues, we first built an EMNLP-based retrieval model where we encountered several limitations. So incorporating the auxiliary captions often yields only marginal gains where even when descriptive captions are provided, replacing them with random captions results in nearly identical retrieval performance. So this suggests that the model struggles to distinguish the caption's role as auxiliary context and the text query as the retrieval target, so leading to an inefficient use of additional information. To remedy this, we introduce a simple yet effective retrieval role embeddings. Specifically, we assign role embeddings RC and RT, which are added to the tokens of the caption and the text query respectively. And we also further adopt a pairwise probability margin between true and false token pairs, which has empirically been shown to improve performance. To further enhance auxiliary captions for retrieval, we propose a preference optimization method that trains the captioning model to better align with the retrieval objective. So specifically, we introduce single group DPO, SGDPO, which is a variant of DPO where DPO aims to increase the probability of the winning sample compared to that of the losing sample. So here in SGDPO, the preference pairs are constructed by comparing caption outputs based on the retrieval relevance scores as preference signals for the given video. To implement SGDPO, we first built a retrieval score-driven preference dataset. So for each video, we sample k different captions and compute a relevant score for each caption against the text query while masking the video tokens in attention, which is denoted as SP here. And using these preference pairs, we train the captioning model. So importantly, both captions in a pair are conditioned on the same video VI, ensuring that the optimization captures local retrieval ranking. Then we propose our dual group DPO, DGDPO, which builds upon SGDPO by considering preferences across distinct video caption pairs. So DGDPO leverages retrieval relevance scores across the dataset to capture global retrieval rank preferences, enabling the model to learn from both local and global ranking information. So the preference pairs in DGDPO are formed from captions with different indices denoted as I and J pairs, highlighting that the model compares captions across different videos rather than only within a single video. Notably, the preference pairs in DGDPO include both cases where I equal to J and I not equal to J. So whereas SGDPO only considers pairs with I equal to J. And this results in cases where a caption that wins according to the local retrieval rank preferences may actually lose under the global retrieval rank preference. So overall, DGDPO enables the model to learn preferences across video caption pairs that optimize retrieval relevance, taking into account both local and global rank preferences. And this combined consideration enhances overall retrieval performance. So the results show that our KDPO outperforms baseline models across multiple datasets, with particularly strong improvements in recall at 1 for both text-to-video and video-to-text retrieval. And we also show a Bayesian study on the role embeddings. So with the conventional EMNLP-based retrieval models, when replacing the captions with random captions, the model experiences only a minimal recall at 1 drop of 0.1 on average. In contrast, retrieval with the model trained with the role embedding shows significant performance improvements while adopting the same caption, especially shown in text-to-video retrieval with 83.1 in recall at 1. We also note that the model show high sensitivity to the quality of the caption with an increase of 1.8 in average for recall at 1 when replacing the random captions with the correct relative captions. On the left is an ablation study on captioning training objectives. SGDPO, which leverages local retrieval preferences while adopting the retrieval score as supervision, improves average performance with 0.9. Yet with DGDPO, which incorporates global retrieval preferences, the model achieves even higher gains. For challenging cases with highly similar videos, adopting the DGDPO yields higher model confidence, regardless of the preference score adopted. Yet with DGDPO, with the retrieval score, results in best performance of 84.5 in T2V and 77.4 in V2T, with the model average confidence of 89.6. So this figure compares baseline and DGDPO captions for visually similar videos. While the baseline provides general descriptions, DGDPO trained captioning model captures the fine-grained details such as revealing cookies inside, placed on a plate using a spatula, and importantly, individuals standing or interacting within the bustling environment highlighted in blue, which actually closely matches with the text query shown in the underlines. So these descriptions help the retrieval model correctly identify the ground truth video, improving the overall performance. So to the best of our knowledge, we are the first to address the gap between conventional captioning metrics and the retrieval objectives. Hence, we propose KRDPO, which is a retrieval framework that integrates role embeddings with retrieval-aligned caption optimization to leverage auxiliary captions in EMNLP-based text-video retrieval. Especially, DGDPO compares against distinct video caption pairs, which enable generations of captions that better reflect retrieval importance. Thank you for your attention.